Okay, I think it is done, right? So this is a solar thermal power plant. Okay, there will be number of receivers. So receivers means number of solar panels in our campus. In the topmost floor, you can see there are around 150 solar panels. Okay, like that number of solar panels will be mounted one after the other. When the solar energy falls onto this, okay, the primary fluid, okay, usually oil will be used. Okay, that will be heated up, and that primary fluid will be passing through a heat exchanger. Okay, we call it as closed heat exchanger because here there are two fluids. Say for example, one is primary, say some oil or water. Secondary is some alcohol like butanol, okay, whose boiling point is very less. At a temperature of 60 or 70 degrees, it forms steam. Okay. So these two fluids will not mix. So what do you mean by this resistor like symbol? So in a pipeline, it will be passing. So it will this pipeline will be made of very high conducting material, which can pass on the heat easily, so that the secondary fluid will take over the heat. Okay, so a simple sketch, a closed heat exchanger means there will be a pipeline, say metal pipeline, it will be passing, and the secondary fluid will be passing through the tank, so that when it comes in contact with this pipeline, it will absorb the heat. So that is what it is represented in this heat exchanger. Okay, so in the solar panel, heat will be absorbed by the oil. That heat will be given to the butanol or whatever alcohol, low temperature boiling fluid that will be used. So that forms a steam, and that steam will be passed through a steam turbine. Okay, so that steam expands in a steam turbine, and electricity will be generated with the help of a generator. Okay, so as we discussed earlier, you cannot. So the output of this will be a combination of steam plus particles of steam plus liquid. So you cannot pump it. So in order to pump it, what you have to do, you should cool it, completely convert to a liquid, then only you can pump it. Okay, the same mechanism is used here. So this is for thermal energy storage and utilization. So this electricity you can store in a battery, or directly you can connect it to a grid. Okay, so depending on application, you can decide. Okay, for example, in our college only, there are over 150 panels. Whatever electricity we are using, it is coming from solar energy only. The excess part of electricity will be uploaded to the grid. It will be connected to the grid. So like that, we can use it. Okay, so this is regarding thermal storage. The last application is solar distillation. It comes under agricultural and industrial applications. Solar distillation. Take down the sketch. So usually this distillation mechanism will be used to convert salt water to potable water. That is, you can drink it. So it's a very simple mechanism. Whenever you visit mechanical department in energy lab, we have done 2 to 3 models of this type. You can just visit it. So there will be a container. So this part of it is a container, usually made of metal, right? Okay. So there will be a hollow space in between, right? So this will be filled with some insulating material like glass, wool, or a straw, etc., wherein the heat will not be transferred through this wall. Okay, so it will be insulated, and there will be a glass cover to completely close this. right? So salt water will be loaded through the filler, and this will also be through a rubber cock, right? So if you load extra water into it, there will be a overflow channel also in this. And this entire mechanism, it looks like a cooker. Okay, so this entire mechanism, it will be placed in sunlight. So what happens here? Actually, as we discussed earlier, the low frequency waves, I mean solar radiation, enter into this. Okay, but when it gets attenuated, it cannot go out. So many times it reflects and it will be absorbed here. So that water gets started heating up. So that here number of layers will be formed. So the bottommost layer will be concentrated with salt water. Okay, so the hot water, which is lighter, which is free of salt, starts floating and it also evaporates. So here there will be some grids made to collect the pure water. If you take out the top layer of water, it will be free from salts and it can be potable. You can drink it. Okay, so one more mechanism that is done here is complete vessel. The inner part will be black coated, so that what happens, the more amount of solar radiation will be absorbed here. So in other words, it is also called as water still. Okay, all solar distillation mechanism. It's a very simple mechanism. So here the main thing what happens is number of layers will be formed when you start heating. The bottom salt concentrated water settles at the bottom and salt free water starts floating at the top. Just take down any doubts you can ask me. With this applications we have completed. There is one small topic left out. Okay. Solar pond, there is a video I'll circulate. You can go through later on how a pond works. Okay. So the last topic in this module, that is module 2, solar energy systems, is how to store the solar energy. So far we discussed few applications wherein we used to heat water, okay, purify the water, then air conditioning, refrigeration applications, like that, many supplying hot air, etc. If you want to store it as electricity, what are the best mechanisms? So there are two methods of storage. One is called as sensible heat storage and latent heat. I think in elements of mechanical engineering, you have studied the difference between sensible and latent heat, correct? So sensible heat is nothing but by virtue of the heat capacity of the storage medium. For example, if you take water, heat it up to 30 to 100 degrees. 30 degrees is the room temperature, up to 100 degrees centigrade. Whatever heat is there in the water, it is called as sensible heat. Okay. Further, if you start heating, what happens? It gets converted to steam. That is called as latent heat. Okay. The heat required to change the phase of a substance is called as the latent heat. Okay. Sensible heat is the heat capacity of a system. Without changing the phase, it can take up that much quantity of heat. Right. So in the first type of storage, the temperature of the medium changes during heating. Just one simple graph. If you see the heat versus temperature graph. Okay. T versus Q, I'll take it as, if you start supplying heat to the water initially, for example, say it is at 30 degrees centigrade temperature. If you start supplying the heat, there will be increase in temperature. After some time, even though you heat it, okay, so after it reaches 100 degrees centigrade, even though you heat it, there will be no rise in temperature. Temperature of the water remains same. Okay. Then after that, if you start heating, you can see the rise in temperature. What happens during this phase? There will be a change in phase of the substance. So this is called as the latent heat and this is called as the sensible heat. Just to make you understand, I am telling you, sensible heat is the heat capacity of the system. Without changing the phase, it can store the heat. After some point, if you start supplying the heat, the change of phase of the substance takes place. That is called as the latent heat. So either you can store the heat in the form of sensible or latent heat in case of solar energy. Some simple examples I have listed here to make you understand better. Okay. So these are the various techniques used for storage of the solar energy. This chart you can take down. I'll give you 2 minutes. So this is the overview of major techniques of storage of solar energy. So as per our syllabus, we have to study only this part, thermal energy storage using sensible and latent. So all these methods, there are different, you can use capacitors, inductor storage, battery storage, chemical storage. Chemical storage means some materials, when you supply heat, they expand. Okay, it can be stored in that whenever you want heat, you can take it up back so that it again contracts like that. Electromagnetic storage. Also, you can store it in the mechanical form by using compressed air or a flywheel, okay, which stores in the form of pumped hydroelectric storage systems, etc. So there are many, only just example of water. So already pebble bed storage we have discussed, rock storage mechanism. Okay, so some more important, say, simple examples I have listed to make you better understand. Okay, so what are the benefits of this storage? You can rely upon the system more. Okay, why solar water heating is not becoming popular? Only in urban areas you can find here and there, but in rural areas people don't prefer because they have to invest 18 to 20,000 and reliability is less. Okay, throughout the year you cannot depend on it. So such reliability issues can be resolved if there is any storage mechanism. Whenever good amount of solar energy is available, it can be stored, and whenever it is not available, it can be used. Generation capacity can be increased. This point you can generally understand, correct? So if you install a solar water heater during the morning time, where during taking bath only it will be used. Throughout the day, whatever energy storage is there, all that will be wasted. In order to avoid that, you can use a storage mechanism, and for some other purposes we can definitely use it, and cost of generation can also be reduced. These are some simple observations. Okay, sensible heat already we discussed. Okay, is achieved by heating a storage medium like liquid sodium, molten salt, etc. Okay, energy is released and absorbed by the medium, right? Sensible heat can be stored in either solid media. So this example we have already discussed, packed bed storage or pebble bed we call it as. Through the rocks, air will be passed so that rocks gets heated up during the night time whenever you want solar energy. So that rock, whatever hot energy is there, so the same thing will be taken back. Okay, so 1 second, I'll just go back to the sketch to demonstrate you. See this mechanism, whatever we discussed earlier. Yeah, so there will be a storage tank with a good amount of pebbles. Whenever you don't need solar energy, whatever here fluid is there, that will be passed through this rock storage. So that rock gets heated up. Okay, it has a very good storage capacity. In the night time, whenever you need energy through that rock, if you pass secondary liquid, that gets heated up and the energy can be utilized. Okay, so this is called as pebble bed or rock storage. Okay, so you can use concrete also for the storage of solar energy, concrete blocks. Okay, so like that, or we can use molten salts also for sensible heat storage. So these are the various mechanisms through which we can store the sensible heat. So one just simple example I have taken, pressurized water storage. What happens in this? A simple example, when you start pumping the fluid forcibly inside this through hot water, what happens? Its pressure increases. Okay, you are pumping the steam here. When the pressure increases inside, okay, its boiling point also increases, so that steam gets converted to a liquid, and in the form of droplets it will be stored. Okay, you will be keep on pumping so that pressure increases and it will be stored in the form of a liquid. Whenever you want it to use, you will just open the valve, pressure will be rapidly released, so that water particles will get converted to steam, and that can be used in a turbine for power generation. So just a simple example to demonstrate the latent heat or storage, I have taken this. Okay, this is pressurized. You need not draw a complicated sketch, very simple sketch with a cylinder. Okay, you can show a cylinder, a relief valve is a mandate. Okay, then steam charging and discharging point you can show. That is enough. This container should be completely insulated, otherwise heat will be wasted towards the outside. Okay, so molten salt technology. Just since I had more time today, the third module was also completed. To make you understand, I have taken some general examples. Okay, See, some of the salts melts at 131 degrees centigrade. It's like barium chloride, etc. If you start heating up beyond that, it forms a liquid. Okay, so that liquid, okay, completely at 288. I have taken one of the salt, barium chloride, as an example. At 288 degrees centigrade, it forms a liquid. So if you heat it to that degree and pass it through a steam generator or a turbine, okay, you can get the electricity. Once it comes out, if it is cooled again, it gets converted back to heat. Okay, so this is called as molten salt technology. Some of the practical example I have given. Okay, different combination of salts you can use. Okay, one example I have taken it from NET, Sandia Laboratories in France. They have developed a salt mixture, okay, with lowest melting point, that is at 72 degrees centigrade. It melts and get converted to a liquid. In an insulated container, you can store it. Whenever you want, you can take it back and use it. Once the heat is taken back, it forms a solid again. Okay, so 30% lithium ion, 50% potassium ions, and 20% sodium ions. Okay, with a 0.56% of nitrate to nitrite ratio. So this formula they have proved, okay, in France for the solar energy storage. So these are all general topics that I had taken to make you understand and give some examples. Okay, so almost we have completed the second module. Just I'll brush up what all we have discussed in this module till now. First, we started with solar radiation geometry. Different angles we have studied: latitude, longitude, okay, equator, Greenwich meridian. They are the four important notations that we have discussed. Okay. Next, solar incident angle theta we have discussed about, altitude angle phi L, declination angle delta, and how to calculate it with the help of Cooper's equation. We call this equation as Cooper's equation. Okay, any given number of the day of the year, if you enter, automatically you will get the value of declination. Okay. Next, hour angle, altitude angle we have discussed, zenith angle, solar azimuth angle, okay, slope and surface azimuth angle. So this I had given you an immediate assignment so that when you write and practice, you can understand and remember well. So this is the important part that we discussed in this module: relation between incident angle theta and other angles. Okay. So some of the important points we have noted: when phi L, that is latitude, north, it is taken as positive. Declination north is taken as positive. Hour angle is positive between midnight to solar noon. 12 night to 12 morning, it will be positive. Again, 12 morning to 12 night, it will be taken as negative. So this we have discussed. And how to modify this equation for a given case. So 4 different examples we have taken and we have modified this. Okay, the same question was given as assignment also. Next, 2 more important definitions: day length, okay, in terms of angle or in terms of time, you can calculate. Local and apparent solar time. Okay, so there will be difference between the local time and the IST. Okay, depending on different points. Okay, so how to calculate it, we have discussed. Some of the numericals on calculation of time, delta, etc. we have discussed. Then we headed with solar collectors. Okay, they are the devices used to collect the solar radiation. 2 types of collectors are commonly used: non-concentrate conventional type or concentrating type, right? Then we had discussed about the principle of energy conversion to heat. Okay, that is greenhouse effect we had taken. Okay, we can in simple words say it is mimicking the nature. In the nature, some phenomena is taking place, greenhouse effect. So you will just compare it with, and you will design a system, right, which works similar to the greenhouse effect, which is useful to the human mankind. Okay. Actually, in greenhouse effect, carbon dioxide gas acts as a glass layer, okay, which acts as a glass layer, which will allow the input radiation and which will not allow the output radiation to go back. The same concept we use in a solar collector, just mimicking the nature, understanding the phenomena of nature and just mimicking it in order to get whatever we want. Okay. So this principle of conversion with respect to solar, greenhouse effect we had discussed. Next, solar flat plate collector, how it works. Okay, we had discussed with a sketch what are the different components and how it works. Next, we went solar flat plate collector is a non-concentrating type collector. Then we started with concentrating collectors. Okay, so in that we had discussed about classification. There are two types. One is focusing type, and the second is the non-focusing type. So both the modules we have discussed here. So in line focusing type, we discussed about parabolic trough collector, cylindrical parabolic concentrator, fixed mirror solar concentrator. So this we compared with the first mechanism. Next, Fresnel lens collector we have discussed. Paraboloidal dish collector, similar to your dish, whatever we use, sun direct or Tata Sky, it looks similar to that. Okay, hemispherical bowl concentrator. To make you understand, I have downloaded a image also. You can clearly see how this mechanism works. Okay, then what are the advantages of concentrating collectors over the flat plate collectors? So this is one of the important criteria. And what are the limitations? Why should we go for concentrating over flat plate? We will come to understand. Okay, then we headed with application points of solar energy. Okay, so a chart with different types of applications. Then we discussed about first water heating mechanism in solar. So natural circulation type. Okay, and non-pressurized, okay, which works due to gravity. Two mechanisms we have discussed. Next, space heating. Without, it's a passive system without any pump, without any motor, without any circulation mechanisms. It's just a passive system. Okay, just due to density difference, the circulation of air takes place. You need not spend any money. Okay, during the winter, whatever small amount of solar rays come, with that you can get the heat. Okay, roof storage mechanism we discussed. In solar passive heating, what happens here, during the daytime only you can expect, nighttime you cannot expect any hot air, correct? Even though wall will be heated over a period of 1 or 2 hours, it just gets cooled off because of air circulation, right? So but here roof storage, what happens, we use water in plastic conductible bags, so that the water will be heated and the roof will be made of metal, which is a good conductor. So if the water is hot during the night time also, you can expect the heat to be in the room. Okay, it is most probably used in many of the Western countries. Okay, roof storage water heater. So this we had discussed. Next, basic hot air system. 1 second. So basic hot air system. See, in this also, we had discussed about the storage of solar heat. Okay, sensible heat, only this part of the, please make a note of it, this part of the sketch you can draw and demonstrate for the sensible heat. Okay, storage, you can use either the pebbles, rocks or concrete blocks here. When the hot air is passed through this hot air or hot water, the rocks get heated up. During the night time, the secondary fluid can be passed through the same bed and you can get the required heat. Okay, so this is one of the sensible heat storage mechanism. Only this part of the sketch you can draw and you can demonstrate. Okay. Next, we had discussed about vapor absorption, air cooling, then solar pond, solar chimney. Okay, thermal storage today we discussed. Okay, solar distillation applications. Then today we have discussed about the storage of solar in the form of latent heat and sensible heat. So just I'll display a video related to solar pond. You can just go through. Can you see it? As I told you, you can see here different layers are at different temperature. Bottom layer is at 90 degrees centigrade. so that water gets boiled. Okay, clearly in this video you can zoom and see bottom layer is at high temperatures of 90 degrees or so that the topmost layer will be free of salt. Okay, the water which is free from salt starts floating. That free salt water you will be taking and passing through a small turbine. You can see the turbine arrangement also here. You can just refer to that arrow which I am passing. Okay, so the turbine output will be given to a generator which gives electricity. You can see here. Again, the same water will be recirculated back. See here, heat exchanger I was explaining. So this is the concept of heat exchanger. You can see here there is a pipe and a small blue color you can see inside. So the water is passing through this, and some other alcohol like butanol is entirely surrounded to the pipe. Usually this will be a metal pipe, okay, which can conduct electricity, so that this forms a steam and it enters into the turbine. Okay. So in this video, just I'll circulate to the group. You can just go through solar pond concept of working, how different layers are formed. Everything is explained. You can just see. Low boiling point fluid is used as a medium.